All right, in the last explainer, we talked about i3X being this vendor-agnostic REST API for all your manufacturing data. So now, let's get into the good stuff. We're going to pop the hood and see what really makes this thing tick, the data model itself.
Okay, first up, the core address space. This is really about going from the blueprint to the actual bricks. The whole foundation of the i3X system is this thing called the address space. You can think of it as the giant container for, well, for everything. And it all starts at the very top.
So this address space has a pretty simple three-layer hierarchy. Right at the top, you've got namespaces. These basically just scope the whole model with a URI like earn plant production. Then you have object types. These are your blueprints, right? They define the schema for everything, what an equipment is, what a sensor looks like. And finally, you get to the real stuff, object instances. These are the actual physical or logical things in your world, like Pump 101.
Let's zero in on that object instance for a second. This is the atomic unit of the entire model, and I mean everything. A physical pump, a logical work order, you name it, is an object instance. And here's the kicker. For any of this to work, every single one of them must have these 6 specific fields to identify it and put it in its proper place.
And here they are, the big 6. You've got element ID, which is just a unique string to identify it. Display name, so we humans can actually read what it is. Type ID is super important. It points back to the schema, its blueprint. Then parent ID links it up in the hierarchy. Next, there's this little Boolean, is composition. Don't worry, we're going to come back to that one. It's a big deal. And finally, namespace URI, which just tells it what neighborhood it lives in.
All right, so now we know what our objects look like. But how do they all connect? Let's talk about the 3 kinds of relationships in i3X. Okay, there are 3 types, and it's really important to get the difference. First up is organizational, or has children. This is your standard folder structure, right? A plant has a building, which has a production line. They're all separate things, just grouped together. Then, and this is the key one, you have compositional, or has component. This isn't just grouping. This is when the children are literally part of the parent. Think of a pump. It's composed of a motor and a sensor. And for this to work, the parent pump has to have that is composition flag set to true. Finally, you have non-hierarchical. These are custom graph-like connections for everything else, like linking a pump to the technician who maintains it with a maintained-by relationship. No hierarchy there at all.
So, why does that distinction between organizational and compositional even matter? I mean, really, who cares? Well, you're about to, because it completely changes how you get data, all thanks to a little parameter called max depth. So check this out. When you query something with the default max depth to 1, you get, well, just that one object. That's it. But if you flip that switch to max depth equals 0, which means infinite, the API recursively grabs that object and its entire tree of components all in one single API call. You can get a complete picture of a complex machine just like that.
But, and this is the golden rule, you absolutely have to remember this, that powerful recursion only works on has-component relationships. It will not follow those organizational has-children links. And that's on purpose. It's a safety feature, so you don't accidentally ask for the plant object and try to download your entire company in a single API call.
Okay, we've got the structure, we've got the relationships, but what about the actual data, the values? Well, every single data point in i3X comes in a neat little package called the VQT structure.
And that package is called a VQT. It stands for value, quality, and timestamp. And it's brilliant, because let's be honest, a number by itself is pretty useless, right? Is that temperature reading good? When was it taken? VQT solves that. Every single value, whether it's live or historical, comes with this essential context baked right in. And that Q for quality is so important. It tells you if you can trust the data. i3X just uses the standard OPC UA codes, which is great. So you get the basics like good, bad, and uncertain. But you also get really useful ones like stale, calculated, or even manually entered. It gives you so much more context than just a raw number.
So let's just recap the whole thing. You've got namespaces for scope. You've got object types as blueprints for your object instances, the real stuff. Those instances are all tied together with 3 different kinds of relationships, and every piece of data they hold comes as a VQT. That's it. That's the entire model in a nutshell.
So now you understand the structure. You've got all the building blocks. The real question is, how do you use these relationships to build some seriously efficient and complex queries?
That's what we'll get into next. But if you want to jump ahead, you can find the full spec right now at i3x.dev.